In this part, we will learn about test-driven development with dependencies with an example. Well, in order for us to work around dependencies, as we will do in this particular part, we need a problem where there are dependencies. So we'll first define the problem, understand what the dependencies are, and then we'll talk about a series of test cases to write and how to approach the testing of this code by working around the dependencies. So let's start with the problem first of all. Imagine for a minute we are asked to implement a service which is going to provide currency conversions. A user would tell us what currency they want, and they want to convert US dollars into that particular currency. Given a dollar, how much can I get for that currency is the question. But our service actually doesn't provide the actual conversion, but it uses third-party services. Of course, our service requires certain profit as well to be made. So the idea behind it is as follows. When a request comes in for a particular currency, for example, let's say Norwegian kronos, and $1, how many kronos can I get is the question the user asks us. We're going to implement the currency exchanger. Well, the currency exchanger is going to talk to service, and there could be many services. It first makes a request to a vendor 1's service and says, hello vendor 1, I want conversion of a US dollar to Norwegian kronos. How many can you give? Well, imagine, for example, the vendor says, I'll give you 5.22 kronos. Hey, that's great. Now, I want to check with the second vendor. Hey, vendor 2, what can you give? Well, unfortunately, we ran into an error and the vendor 2 doesn't really get through. We want to know something really went wrong, so we're going to log the error so that an administrator can look at this. If over a period of time, there has been errors being reported for vendor 2, they can try to investigate and fix it. Then the service requires information from vendor 3. There could be any number of vendors, but in this case, vendor 3, and that gives us a better rate than vendor 1 did. So it takes the value, marks it down by 2% per profit, so 5.76 kronos, reduce it by 2%, and the result is 5.65 is what the user is going to receive as a response, and the user can now decide whether they want to go with this or not. So let's say this is the system we want to implement. Our entire focus is on implementing our currency exchanger. How do we go about programming test-driven the code for the currency exchanger to receive a currency and return the value, the currency value that they would get in return? That is the problem that we want to solve here, with the 2% markdown and different services and some failing, some giving us results, and we want to pick the one with the best result. How do we approach this? That's the problem we want to solve in this particular example. So let's see what we're going to start with. We need a set of test cases to begin with. So what kind of test can we start with? Well, take a few seconds. If you want to pause the video, please do, and think through what kind of test you would probably write. And once you come up with a few test cases, we can compare notes and move forward. So what kind of test cases would we start by writing in this case? Well, we can see that we want to start with receiving a getRate method. And the getRate method would take a currency as a parameter. And what we really need to return is the value. But internally, what does the getRate have to do? The getRate has to first go to each of the vendors and ask for the price. And if a vendor fails, it's got to log it. Take all the prices, get the maximum value of the price, mark it down by 2%, and return the result. Yeah, that seems like reasonable, isn't it? So let's think about some test cases we can start with. The first test case I can think of is markdown. Let's call it as markdown. Let's say by 2%. A value of 100. We could say mark down by 2% a value of, let's say, 50, and maybe mark down by 2% a value of 0. So that would include a bit of a negative test as well. What happens if the value is 0? What do you want to do? Well, that could be a first series of tests. Then we could say mark down when there is no vendor. So that's the first thing. And then mark down, getRate. So getRate when there is no vendor. And then we could say getRate when there is one vendor. We could also say getRate when there is one vendor with error. What do? There's only one vendor, but that failed as well. So getRate when two vendors with first having a higher rate, and then get rate when two vendors, and then with second having, let's say, higher rate. So these could be a series of tests that immediately come to my mind. Where do we start? Let's start with a very simple test to begin with, one that wouldn't drag us into the complexities of dependencies and things we have to deal with, but let's us moving towards creating certain workable solution. Of course, we could create a canary test to begin with, so let's start with that first. So let's go ahead and say we want to create a currency exchange. So let's create a test class. We'll call it a Java class. We'll call it as a currency exchange test. And that's the first class we want to start with. Well, within the currency exchange test, we want to start with our canary test. So let's go ahead and say canary right here. So here is our canary. And what do we want to do with the canary test? Obviously, all we're going to do is assert true is true just to get us moving forward. And so let's go ahead and start with that. Well, what does the assert true complain about? It wants to know where that's coming from. Let's bring in a static import. So we got the tool set up properly. Let's go ahead and fire up the test, and we can see the test just passing. So we got something rolling. But we got to come to the real test. Where do we start with the real test? The very first test I would like to start with is the markdown. That, after all, tells us when we have determined a high price, we want to mark it down by 2% for profit and return it. So obviously there's no real reason to deal with dependency at that point. We can clearly write the markdown method. So let's get that going first of all. So let's go ahead and create the test for markdown. So we'll go ahead and say markdown for, let's say, for profit. Let's say for amount or rate of 100. So markdown for profit for rate of 100. So we're going to say assert equals and 98.0. And then, well, we typically want to be dealing with full cents when it comes to financial applications. We don't really want to deal with double values. That becomes pretty sticky in terms of how to deal with it. So we will assume that we're going to be dealing with all the cents or the pennies included in it. So we will say 9800 comma, and then we're going to say currency exchange dot, we'll call markdown for 100 with 2 zeros including the cents in that place. So notice the very first few tests help us to deal with the interface and make these little decisions along the way. Well, obviously we want to know what assert equals is. Let's go ahead and bring the static import for that. That brings us to the currency exchange. Let's create a field for currency exchange. So currency exchange, there we go. And we need an object of currency exchange. So let's go ahead and bring in the before method, and we will call this as unit. And within this, we will say currency exchange equals new currency exchange. Let's create an object of that type. Well, the currency exchange is going to be a class we create in the exchange package within the source directory. So that's good. And the next thing we really need here is the markdown method. Let's go ahead and create the markdown method. It's returning for a value. We'll call it as a rate. And all we are going to do is return from here a 9800 to make the test to pass. So let's go ahead and run the test this time to make sure the tests are passing. And that's perfectly fine. So we finished our first test, and that helped us to determine the method called markdown. And we made a little tactical decision there to say, hey, this better be taking a rate value. We also made a fairly important decision that we want to keep this in integers rather than doing a 98.0. Well, markdown for the value of 50. Let's go ahead and get that rolling. So for that, we're going to go back and write another test, and we will say markdown for profit. So what is this for? For rate. So for rate 50 of 50. So this will force us to implement some code. So assert equals, and that's going to be 4900 comma currency exchange dot markdown and given a 50. So go ahead and run the test this time again to see what it tells us. You can see the test is failing. It was returning a 9800 rather than 4900. So to fix that, let's go to the markdown method. And here, of course, we want to take the rate And what do we want to do? We want to discount it by, reduce it by 2% and return the value. So that would be times, and we could say 2%. So 2 divided by 100, that would become the value of the rate that we're going to subtract from the rate itself. So we could say rate minus that particular value. So rate minus the value of rate, whatever that rate is, times 2 divided by 100 gives us the percentage. So let's go ahead and run this code and see what it tells us. And oh, wait a minute, it gave us a 49 and not 4900. Let's go back and see what went wrong here. Well, this is going to be a 2% from the rate. Well, the rate value itself is whatever the value 5000, aha, that therein lies the problem. That should be a 00, so the test was actually incorrect. So let's go ahead and run that through, and we can see the test is actually passing. So that tells us the code is returning what we are expecting to be the right value in this particular case. But of course, the question is, what do we have? What do we do if there are sense differences? So that brings us to yet another test that comes to mind. So mark down by 2% a value of, and in this case, let's say we have a $97 that we have on our hand. So what do we do for a $97 a rate, or 97 as the rate, and we want to mark it down by certain 2%? So let's go ahead and write a test for that. So here is the test, and the test is going to be marked down for profit, for rate, and off, and this is going to be 97. Yep, that's exactly what we mentioned over here as 97. So what should the value be? Well, assert equals, one more time, we're taking away a 2% value from a 97%. So we could bring up a little calculator and use and find out what the 2% value should be. And once you determine what the value is, you can hard code that. So what is 2% of 97? Let me bring up my calculator here and run through it real quickly. And this is going to be 2 divided by 100. And then of course times 97. And that takes away 1.94. And so 97 minus 1.94 is going to be 95.06. But of course, I want to put it all in 1 cent. So I'm going to say 9506, comma, and currency exchange dot mark down. And in this case, we're going to say 9700. So let's go ahead and run the code and see what it tells us. And the test is passing. So that tells us the calculation went on fine. And then we can move on to the next test, which is marked down with a value of 0. So let's end that particular test with that particular value of 0. So mark down again for profit for rate of 0. And of course, if the rate is 0, we're not going to return anything other than 0 itself. So 0, comma, currency exchange dot mark down and send a value of 0. And let's go ahead and fire that up and see what it provides for us. And that test is passing also. So that was easy, and we avoided the real dependency at this point, and we got this little nice function for markdown that's doing the job for us. So when it comes to writing these test cases, do start with test cases that can help you to get moving without being directly dragged into dependency to begin with. But now that we have moved away from that particular little problem, what about the get rate function? How do we deal with it? So this is where we probably have to deal with dependencies, and we cannot postpone it any longer. So get rate for when there are no vendors. So if there are no vendors, what should we really do? Well, there's no vendors. So what do you want to tell the user when the user comes and says, I want currency exchange for US dollars into Norwegian kronos. How much do you give? What do? Well, there are a couple of different options. You could raise an exception to say there are no vendors, but honestly, does the user really care? If you go to the currency exchange and say, I'm here to get some change, please, you don't want stories from the clerk saying how terrible the day was. All you want to know is, you know what, dude, sorry, I don't have any exchange for you, leave. So the point really is, I don't want really any information other than a value of 0 when there are no vendors. So let's start with get rate when there are no vendors, and that should be relatively easy to do. So get rate with when there are, let's say, there are no vendors. So we have no vendors at all. What do I want? So get equals, assert equals 0 comma currency exchange dot get rate, and I want to say NOK is what I want to get the rate for. So notice again, this allows us to define the interface and what parameters we should pass and things like that. So what should I do within the get rate method? Well, within the get rate method, all I'm going to do is say currency over here and return a value of 0. That is good enough for us. So let's go ahead and run this test, and you can see the test is actually passing. So that tells us that with no vendors at all, the code is still behaving the way we want it to. Now, of course, in this case, we didn't write much code, but the point really is the fact that get rate should return a 0 is something that's going to continue to work as we evolve the design and make more progress. And that is the essence of it. For writing this with almost no implementation or real implementation right now is to ensure that that behavior is preserved as the system evolves, as the application evolves, as the design evolves. That's the real point. Now let's get a rate for when there is one vendor. Well, let's go ahead and write the test first. So I'm going to say get rate when there is one vendor. Now, what do we have to do here? If it helps, write some pseudocode first. We have one vendor returning a rate of, let's say 100 is the rate the vendor is going to return. The get rate, so get rate, let's see what's going to happen. So get rate, so here is get rate, should get that value from vendor 1 and mark down to return. So let's go ahead and write the code in a way that we can come back and backfill. So assert, let's go ahead and say equals, and what are we going to do with the assert equals to begin with? Well, the first thing we're going to do with assert equals is we're going to say I want a value of 9800 and currency exchange dot get rate for NOK. Now, obviously, if you run this test right now, it'll fail because get rate is returning a 0 and not a 9800. But also remember, when you read this test, it should be very clear that there is one vendor, and then that vendor is returning a value of 100, and as a result, the result we get back is 9800. It should be very clear and expressive when we look at a test to know what's going on. So how do we proceed? Well, first of all, recollect that our vendor, the currency exchange, is going to talk to one vendor. And that means we need to have a vendor. But how do you introduce a vendor? Well, you don't want our currency exchange to tightly couple to a vendor because we may change the vendors, add more vendors, remove vendors. So we don't want to tie ourselves to a single vendor. What that means is we would need to do dependency inversion principle. And rather than the currency exchange talking to a vendor, we want the currency exchange to talk to an interface, and the vendor implements that interface. Yep, we talked about this before. So we need to inject a mock object rather than the real object. What are the different ways to inject mocks? One is a constructor-based injection. So when you are using the constructor of the object, for example, the currency exchange could take as a constructor parameter. Let's enter it in the start with a little example here. So let's call this as rate service, for lack of better words, and we will call it as rate service equals null. Keep that as null for a minute. Let's create a rate service as an interface in the source directory under exchange. So we have a rate service interface on our hand. We could say new currency exchange, and we could say rate service as a parameter to the constructor. So this is, in a sense, the constructor-based injection. So in constructor-based injection, we pass the mock object as a value through the constructor. So how would this look like if we were to do this? Well, let's go to the currency exchange first of all, create the constructor. Notice that takes a rate exchange, rate service as a parameter. And what we could do here is we could say rate service, we'll call it as the service for now. And then we could simply say the service equals rate service. Now, sure, your currency exchange needs to deal with multiple vendors, but don't worry about it right now. Do one and then we can look at many afterwards. So the service equals rate service. And now, of course, the code can use the service in the rest of the code. That is constructor-based injection. Well, I'm not a big fan of constructor-based injection because it is relatively static or inflexible in that we set the value during construction. It's really hard to change it afterwards. And also, it is not that flexible to work with multiple values. You got to pass a list at that point. I'm not a big fan of constructor-based injection. A better way is a setter-based injection. So what we could do instead is, let's get rid of the constructor here. And rather than the constructor, we could come in here and say currency exchange dot set vendor, and then we could say rate service, for example, or we could call it as set rate service, and then we could so call this as a rate service. Now this is a setter-based injection, as you can see, and we can implement a setter called set rate, and you can see in this case I can say the service equals, and then we could set the particular service value. So you can see in the set rate service we received a rate service and set it to the rate service, the service field, and then now we can use that service elsewhere in the code. That is a second approach, which is the setter-based injection. I like setter-based injection because it's easy to vary this as well dynamically, and so that gives quite a bit of flexibility. Now you could make this setter method a protected method and have it available only through the test, and during integration maybe you can pre-create an object if it makes sense. Those are options you can consider. A third approach is a factory-based injection. Well, the idea behind a factory-based injection is we don't have a setter method like you see up here, and so we don't have the setter method here also. However, within the currency exchange, you would go out to a factory object to get it. So for example, as an example here in the get rate, you could say service factory dot get service, and you would specify this code where a service factory would be a separate class. And of course, back in the test, you would configure the service factory to return either a fake object or a mock object, or during real production run, it would return a real object instead of a mock object. So you can use a factory-based injection. These kinds of approaches are often used with tools like Spring or Guice, G-U-I-C-E, which is a Google-based injection framework. So there are tools available to do these kinds of factory-based injection. I'm not usually a big fan of factory-based injection either, because I believe it adds a little bit more complexity, and if I really don't care for that complexity without much value, I would rather do a simple setter-based injection. However, if you want this object to be available consistently from multiple angles, then a factory-based injection is probably a good idea. Let me explain what I mean by that. In this particular example we are working with, we simply have a currency exchange and we care about only that. But in a large system, let's say you have 5 or 7 classes, and all these classes need to talk to a service. Now, I don't want to be injecting an object into multiple of these 7 classes or 7 objects of these 7 classes, because it becomes pretty painful and inconsistency may arise from it. Instead, it's better to configure a factory as a singleton, and all these 7 classes and instances of them could go to the factory and get the object, and that would be a lot more streamlined way. Again, use your judgment when a setter-based injection is adequate and maybe a factory-based injection is necessary. A fourth approach I won't show you now, but we will look at it later on, is by overriding methods. I'll just leave that thought right now, but keep in mind there is a fourth way, which is overriding, but we'll take a look at it when we look at a good example of using it later on. So what do I do in this particular case? I'm going to simply use a setter-based injection for our purpose. So I'm going to say currency exchange dot, and I'm going to say set rate service. That's what I'm going to call it as now. And in this case, I'm going to say rate service. That's what I'm going to call this rate service as. So we have a rate service given right here. Now that I'm going to send a rate service, let's go implement the set rate service as a setter. And that, of course, is going to set the service that we have created up here in the class itself. So now that I have the service, what do? I still need to tell that the service is going to return 100. So to do this, we need an object of a service. We're not going to really use a real service at this point. So what we could do instead is we could simply set up a mock object for that purpose. So how do I do that? Well, here's an idea. We could say class, we could say rate service mock, and this is going to implement over here a rate service. And so we could implement the rate service object to begin with. So we could say new rate service mock. We can create an object of that. But the question is, what value is the mock going to return? Well, we'll get to that in just a minute. We can go to the rate service method, and the rate service method is going to look for the service. So it's going to say if the service is not equal to null, it is going to say return. And what does it want to do? Get the service, right? So the service dot, and it's going to say rate for currency. Let's call that the method we're going to have on it, and passes the currency to it. And whatever rate it's going to return, we will go ahead and save this value here as the rate, if you will. And then we're going to say return, mark down the rate, and return the 2% value reduced from it. We can return from that. Well, rate for currency is the value, is the function we're going to write on that. So that is part of the interface, as you can see. Notice our currency exchange only knows about the interface. It does not know about the mock objects. Where is the mock object? Well, tactfully, I created the mock object in the same file as the test itself. So right within the test, I created the mock service. And here I have the rate for currency exchange, and it simply returns 100. Let's go ahead and run the test and see what it does. And you can say, oh, wait a minute, it's a 9800, obviously, because I need to provide the proper value to be returned, and that will be 00. Remember, we are dealing with the units in cents or the denomination, not in the full currency value. So you can see it's returning the correct result at this point. Now let's quickly review what we did. Get rate when there is one vendor uses a mock vendor. Looking at the mock vendor, you know it's returning 100 as the value. And so the service is going to use the mock, but it doesn't know it's a mock. It treats it as an interface implementer. And the get rate obviously is going to go to the vendor and ask for the rate, and which is a fake value we are returning from the test over here. And then once it returns a fake value, we mark it down and return it. And of course, during production code, this code will talk to a real service vendor. During test cases, it's talking to a mock. Well, we made some progress, but we can do a little bit better than this. We don't want to be creating multiple of these classes. We can easily move this class inside this class as a anonymous inner class. That's something you can do in Java, for example. But let's come back to that in a few minutes. We'll leave this like this. We'll come back to that after we discuss a few other things. So what did we just do? We hand tossed the mock object in this particular case. And so we created a mock class which was returning a fake or a canned result or a cooked up value. And then we are simply saying, go ahead and pass the mock to the currency exchange. And the currency exchange holds on to this particular object. And then, of course, when it comes back with the markdown result. So we implemented this test when we have one vendor. Now, what's the next test we should implement? We could implement a test when the vendor throws an error, or we could go ahead and implement when there are two vendors. That's a choice we have to make but we will make that choice in the next part of this presentation. In this presentation, we hand tossed a mark. In the next part, we're going to complete this example by doing a little bit more with the marks, and then we'll talk about a few issues we will run into and how to be very practical in creating mark objects as well. So let's do that in the next part of this presentation.